Okay, this does piggyback off the clearing fractions concept that we did yesterday. And again, you could get a common denominator. So maybe last year you got a common denominator here, here, and here, and then just crossed them out, right? Is that what you did? Okay. You can still do that. It's pretty much the same thing here. But if you also just, quote-unquote, clear the fractions by finding the least common denominator of all of these. So 5 and 2 would be 10. Then you got a 3 in there as the least common denominator, 30. Okay? So if you multiply both sides by 30, it's just another technique to throw at you. When you distribute your 30 here, again, your 30 divided by the 5 is going to reduce to a what? 6. So it's going to be 6 times the 3x that's there, which is what? I'm going to write that step down. Right? Because the 30 divided by 5 reduces to a 6. When I distribute the 30 here, what does the 30 divided by the 2 reduce to? 15 times the x minus 3 that's there. And the 30 divided by the 3 on the right-hand side reduces to 10. And now it's just a much more straightforward linear equation as opposed to the rational equation. Okay? So then we would just 18x minus 15x plus 45 equals 10x plus 20. Out of room. I'm going to combine. Connor, do you have a question? Did I screw something? Because negative 15 times negative 3 is a positive 45. And then I'll get all my x's over to the left, so when I subtract the 3x over to the right, I'll have 7x. At the same time, I'm going to subtract this 20 over to the left. I'm going to have 25. And then divide by 7 on both sides. And your answer is 25/7. With rational equations in general, you should look for an extraneous answer. It's one of the scenarios where you can have an extraneous solution. This one, because there are no variables in the denominator, you're not going to have that. But we'll look for that definitely in the second one because we do have variables in the denominator. Any questions on that? Okay. In number 2, and anytime you're dealing with polynomials, it's good practice to factor first. So I'm going to factor this into x minus 3, x plus 1. Kind of change that. So again, I can get a common denominator everywhere. It's the same thing, really, if I do that versus clearing fractions. But my least common denominator of all of these denominators would be x minus 3, x plus 1. So if I'm just kind of practicing this clearing fractions method and multiplying both sides by x minus 3, x plus 1, the least common denominator, things will cancel when you distribute these through. So this times the first term, your x minus 3's will cancel, and we'll just leave x plus 1. Minus, when I distribute it through to here, the x plus 1's will cancel, and I'm left with minus the 2 times x minus 3 equals, and on the right-hand side, x minus 3, x plus 1, x minus 3, x plus 1 just cancel, equals 8. And again, now it's a linear problem. So we'll go ahead and solve that. Subtract 7 from both sides is going to leave you with negative x equals 1, and then x equals negative 1. Now you just need to look back and be sure that that was not one of your excluded values. The excluded values from this problem would be x cannot equal 3, x cannot equal negative 1, and another x cannot equal 3, and x cannot equal negative 1. So x cannot equal negative 1, right? So even though that's the solution we came up with, it's actually extraneous because if you plug it back into the original, it's going to give you an undefined. So you might want to do that and just write extraneous. And so there really are no solutions to this rational. Any questions on this? Okay. Number 3 tends to be something we're not good at. I know it doesn't copy very well because it's right on the line, but that's an F1 plus F2 on the denominator. And we're solving for F2, F sub 2. So I guess one of the main issues is that we've got an F sub 2 both in the numerator and in the denominator. Okay? So when you're solving for something, you need to see F2 all by itself, obviously, but you cannot have any F sub 2's in the equation on the right-hand side. You have to have F sub 2 all by itself. It can't be also in terms of F sub 2. To me, in an English classroom, it reminds me of defining a word with a word, right? You know what I'm talking about? You can't define a word by using the word in the definition. That would not be helpful. So we can't define F of 2 with F of 2 in the definition. So we need to find a way to get F sub 2 all by itself. And now some of you might be good at this. I definitely worked on this a lot with my Algebra 2 kids last year. But let me ask someone. I don't know who yet. William, what would you do to start this? Okay, so you're sort of clearing your fractions, right? Getting this whole thing out of the denominator, right? So he's going to multiply both sides by F1 plus F2. So F times F sub 1 plus F sub 2 equals F sub 1 times F sub 2. Do you know what you do next, Liam? Okay. So we have F sub 1 plus F sub 2 equals F sub 1 F sub 2. So he's going to have F sub 2 equals F sub 1 plus F sub 2 over F sub 1. Yes? And then what? Or is that your answer? What did he just do, though, that I said we cannot do? Jalen? Right, so he's defined F sub 2 in terms of F sub 2, among other things, but that's exactly what I know the instinct is, because we're just getting it by itself, but we cannot do that. So who can kind of backtrack here and tell me where he should have gone throughout this problem? Connor? Oh, okay. Sorry, I thought you were. Maria? Right here? Here. Divide by F. So you would be talking F sub 1 plus F sub 2 equals, and when he divides by F, he'd have F1, F2 over F. And then what were you going to do from here? F sub 1 over? Okay, so you'd have F sub 2 equals F sub 1, F sub 2 over F. Same problem, right? F sub 2 is defined using F sub 2. This is a doozy. So the issue is, I'm going to get rid of this. A little trial and error. Who's got it? Come on. Someone in here. I don't want my Algebra 2 kids from last year to be able to show you up. Come on. You know when you probably did this last year? Let me give you a random question. F of x equals x plus 3 over x minus 2. If you were asked to write the inverse of this, so y equals x plus 3 over x minus 2, switch your x's and y's, and solve for y. How would you solve for y here? I did like Liam's first step, which was to multiply this out of the denominator. So x times y minus 2 equals y plus 3. How would you solve for y? Stephen? No, that's just going to bring me back to the original. Okay, what would you do to solve for y if this x was a 7? What would you do if that was a 7? You would distribute, right? You'd subtract all your y terms to get them on the same side, right? And then you'd combine them, essentially, and then divide away their coefficient. Well, that's going to be the same technique. Unfortunately, you have to just swallow the fact that it's not a number you're distributing an x. You don't have to copy this, just watch. And you still want to consolidate all your y's, get them all together, because you can't have them on both sides. You've got to get it y equals, not in terms of y. So if I'm going to get my y's all together, I'm going to subtract this y term over. So I have xy minus y on the left. I'm going to add my 2x out of there. And again, that x is where your wrinkle's coming in there, because if that was 7y minus y, you would just say 6y. And so the rule that I always said with my Algebra 2 kids is if you can't combine them, factor them. Meaning this, I can't combine those because an x doesn't combine with a 1, really, right? I can't do x minus 1. So if I can't combine them, then I have to factor out the y. So I take out the y, and now my problem only has a single y in it. Now I can divide by x minus 1 over and get y all by itself. Yes? Did you not write inverses of rationals last year?
You did. I blocked that memory.
Does that look familiar?
Yeah.
Oh, you stinkers.
So much trauma.
All right. So bringing us back here, I like how Liam distributed the f. I do not want him to divide over the f sub 1, though. What he needs to do, since we're solving for f sub 2, is get all of his f sub 2's together. So I'm going to subtract this f sub 2 over. Okay, and then I'm left with f sub 1 on the left equals f sub 1 f sub 2 minus f sub 2. So all my f2 terms are together. I can't combine them though, so factor out the f sub 2 that you're solving for so that there's only one f sub 2 in the problem. So on the right hand side I'm going to factor out a GCF of f sub 2, and in parentheses I'm left with f sub 1 minus f. Now I can divide over that binomial to get f sub 2 all by itself. So my motto, if you can't combine them, factor them. But you still have to work towards getting all your f sub 2 terms together. Is that clear? Are there any questions on that? I don't know how many of those problems are going to get hit on the homework questions that you're working on tonight, but just look around that question if you see one like that, and maybe try to do a couple extra just for good practice if you're not super comfortable with that. Because I don't know that it will come up more than once, but I think we could probably work on more of those. All right, how about absolute value? It's been a while. That's not an Algebra 2 thing, unless Mrs. Zig, I threw it in there last year. No, yeah, I wouldn't think so. There's too much other stuff we had to do. To solve an absolute value equation, you have to get the absolute value piece all by itself. So I'm not going to really focus on what's inside here first. I'm almost going to treat it like 4y plus 7 and just get that absolute value all by itself. So subtract 7 first from both sides. Divide both sides by 4. So it's going to be the absolute value of 1 minus 3/4 x equals 3/4. Just one word of caution about absolute values. Make sure you draw them tall enough so that you don't think it's a 1, so that you don't think that's an 11. I see that happen a lot, so just be careful of that. Or do them significantly darker, something, so you don't do a whole problem thinking it's an 11. Once you're here, okay, if I cover this up, the absolute value of what number would be 3/4? Connor said minus 3/4, negative 3/4 is one option, right? Or positive 3/4. So what is underneath my finger right now could be equal to 3/4, and then that equation would be true. Or it could be negative 3/4, and that equation could be true. So this is very common for absolute values. They usually yield two different answers. Because what's under my finger, this 1 minus 3/4 x, could equal 3/4, or it could equal negative 3/4. And we have to solve both of those separately. So absolute value equations branch out into two separate linear equations. And now the absolute value signs are gone. Excuse me. So I'm just going to solve that. Subtract 1 from both sides. What is 3/4 minus 1? 3/4 minus 4/4? Negative 1/4. Very good. And how do you guys go about getting rid of a fractional coefficient? Yeah. Right. It's kind of like that keep change flip. We could divide by negative 3/4, but then that's just going to be multiplying by the reciprocal. So we multiply both sides by negative 4/3. And x could equal, the negatives cancel, the 4's cancel, 1/3. Or, solve the other option, subtract 1. And negative 3/4 minus 4/4 is what? Negative 3/4 minus 4/4 is how many fourths? Negative 7/4. You think fractions are so much harder than they are. And then again, we're going to multiply by a reciprocal. Negative 4/3. X equals, again, our negatives are going to cancel, our 4's are going to cancel, and we get 7/3. So there are two solutions. Okay? Absolute value equations can sometimes yield extraneous, but you would almost notice it back here if it was going to happen. If you ever have that the absolute value of something equals a negative number, you don't want to move forward, right? That's just never going to happen. Absolute value of anything equals either 0 or a positive number. So, but if you kind of overlook that and you just kind of jump forward with the process, you might miss it. So if you want to check it, you can. But if you ever see absolute value of anything equaling a negative, stop. No solutions. Can't happen. Okie doke? All right, with quadratics, we should know 3 methods without the calculator. A calculator method would add an additional 4. We know how to factor, solve by factoring, I'd assume, in our sleep. Completing the square might be a little bit rougher. but with good reason. It's not really necessary as much. So, you know, honestly, I don't really even care to show you that if you don't already like it. And the quadratic formula you could probably do in your sleep. What do you guys prefer, factoring or the quadratic formula? Hopefully factoring, if it's factorable. If it's not factorable, well, you have no choice. You'd have to do the quadratic formula. So anytime you're factoring, what has to happen first? Am I just...
Everything has to be on. It has to be
set to 0. So I'm going to subtract over my 8x, add over my 15, and get it all equal to 0. Now, is this one factorable? Raise your hand if you can tell me. Ellie. Very good. X minus 5, x minus 3. And then since we're solving, the directions are to solve, not to just factor. Solve, we actually have to come up with solutions. So x equals 5 or 3. I put a little asterisk here with the word discriminant. What does the discriminant tell us again? If it has solutions and the kind of the nature of the solutions. Are there 2 real solutions or 2 imaginary solutions or just one solution? So just a couple notes on the discriminant. If the discriminant, I'll use D, is greater than 0, that means there are 2 real solutions. If the discriminant is less than 0, what does that tell you? 2 imaginary solutions. And if the discriminant equals 0, what does that tell you? 1 real solution. Right? That's because in the quadratic formula, which you're not going to ever have given to you anymore, that's because this is D, right? And if you're taking the square root of a positive, then you'll have 2 answers because you'll have this plus that number and this minus that number all over 2a. And if the discriminant is negative, obviously the square root of a negative number produces your imaginaries. And then if your discriminant is 0, the square root of 0 is 0. So your number plus 0 and your number minus 0 really just yields the same thing twice. Hence the reason we only have one solution. Okay? Do we know the quadratic formula by heart? Even though, for some odd reason, New York State, it's on your Regents. Gosh, we're running out of time here. I'm going to quickly, you get this radical all by itself. If you guys just want to watch and then you can go back and watch the video, you can, because I'm going to fly here for the sake of time. Get the radical all by itself. Square both sides. You have to be careful here because when you square this side, you have to square the trinomial out. Use your shortcut. And then it became a quadratic, and I'm going to solve the quadratic from there. I do. Sure, no problem. Thank you. Woo, we almost had a casualty. So when things turn into quadratics, we're going to have to check these solutions to see if they're extraneous. Okay, but get that equal to 0, solve by factoring your formula, and check for extraneous. On 7, I've got x's on both sides. I'm going to square this side out first. Again, it's a quadratic. Get it equal to 0. Solve. Check your answers. So these are all, a lot of things turn into quadratics. Once we address the radical, it turns into a quadratic. This one was a quadratic kind of to start. Another absolute value. what is underneath my finger could equal 8 or it could equal -8. So that's going to produce two separate quadratics that we have to solve. So it's quite possible that this will have 4 solutions, right? 2 from this quadratic, 2 from that quadratic, check them all. And this last one, I don't know if you did this last year, and on the August exam, it was a nasty little question. I know you solved radicals, but when there were 2 radicals in a problem, I don't know that you did that. You still have to get a radical, I don't care which one, you have to get one all by itself, and you still have to square both sides. Now, on the left-hand side, that's all well and good, because you just have x plus 5. On the right-hand side, that's pretty nasty. You have to square a binomial containing a radical. So when I FOIL there, I get 4 plus 2 of those, plus 2 more of those, which is going to make 4 root x minus 3's, plus root x minus 3 times root x minus 3 is just x minus 3. And the thing is here, it hasn't gotten rid of the radical problem. But at least now we only have one of them. So I'm going to get this all by itself again. I'm going to subtract over my 4. I'm going to subtract over my x. And I'm going to add over my 3, which is going to give us 4 equals 4 root x minus 3. Now I can divide by 4. I'll get 1 equals root x minus 3. And I'll square from there. Okay, I'll square both sides again. I'm just going to finish this for the sake of the video.